Hello, so today in this video, we're going to differentiate the function, the modulus of x to the power of x with respect to x. So in the previous couple of videos, we differentiated the modulus function. So we differentiated this function and we found out that we got this result here, so the modulus of x over x. Of course, x can't be zero in this case. And we also differentiated the x to the power of x function. And the result we got was this. So x to the x multiplied by 1 plus the natural logarithm of x. So that's the results, or they are the results we got in the previous videos. So these results will come in handy in this video today, where we want to differentiate the modulus of x to the power of x. So let's go ahead and do this. So we know that when we differentiate, or we know that when we rewrite this modulus of x to the x expression, this is just exactly the same as essentially saying e to the power of ln mod x multiplied by x, like so. Okay, so now what that means then is that when we differentiate this function, this derivative is just the same as that derivative, of course. And then what we've got here is the exponential function. And inside that exponential function, we're inserting this function here. So the log of the modulus of x times by x. So this is a chain rule problem. So again, we're going to use the chain rule. And we've used this lots of times before in previous videos. So the chain rule. And to do this, we're going to differentiate the ln x. So ln mod x times by x. And that's going to be differentiated with respect to x. And then we're going to differentiate so the exponential function to the power of, or the exponential function of this ln mod x multiplied by x. And that's going to be with respect to the ln mod x times by x, like so. Okay, so we get that. So differentiating this first part here, so this natural log of the modulus of x times by x. So this is now the product rule. So you've got the product of two functions there. So using our product rule then, so we know that this is going to be the derivative of ln mod x times by x plus the derivative of x with respect to x times by ln modulus of x. And then that's the first bit, which we'll simplify in a minute. And then this second bit over here, so the derivative of e to the ln x times by x with respect to ln x times by x. Well, we know that when we differentiate the exponential function with respect to a variable, we just get the exponential function again. So this is e to the ln modulus of x multiplied by x, like so. So I mean, this second bit is actually just going to be the modulus of x to the power of x. And then this bit inside the brackets here. So we're differentiating the modulus of x. So again, this is kind of a bit like a chain rule example. Again, we go to a new page. So we know that when we differentiate the log function of a variable, we should just get 1 over x. But this time we're differentiating the natural log function when we insert the modulus function. So this is just the same as differentiating the modulus of x with respect to x multiplied by the natural log of the modulus of x with respect to the modulus of x. So that we know that when we do this second part here, we just get 1 over mod x. And we know that when we do this first part, so differentiating the modulus of x, so if we go back to over here, we get the modulus of x over x, like so. So the modulus of x over x, like that. What do we notice? Well, these modulus of x's cancel out, and we just get 1 over x. So in fact, the derivative of the natural log of the modulus of x is also 1 over x too. We'll actually come on to this in a future video. But yeah, so when you differentiate this function, you get 1 over x. So what we've got here then is we've got 1 over x inside there multiplied by x, and then you've got dx by dx, that's just the number 1, and then multiplied by the natural log of the modulus of x there, multiplied by the modulus the modulus of x to the power of x. What we notice is that these x's there just cancel out to give us a 1. And so what we can conclude from that is that when you differentiate the modulus of x with respect to x, sorry, the modulus of x to the power of x with respect to x, then you should get the result that we got down here. So the modulus of x to the power of x multiplied by 1 plus the natural logarithm of the modulus of x, like so. And that is the final result for today's video.